Let's create an AI web scraper app using Python and machine learning. We import Flask for the web framework, requests for fetching web pages, BeautifulSoup for parsing HTML, TF-IDF vectorizer for keyword extraction, NumPy for array operations, and for text cleanup with regex. This initializes the Flask application, so we can define routes and handle HTTP requests. We define a proxy configuration that routes all outgoing HTTP and HTTPS requests through a specific proxy server, useful for bypassing IP restrictions during scraping. Now, quick mention. For this project, I'm using ipcook proxies. If you're doing scraping or automation, you'll quickly run into blocks or rate limits, and that's where ipcook proxies comes in and become essential. You can go to ipcook.com, do sign up or log in, and once you're on the dashboard, click on Residential Proxies. Choose a plan. I'm using the basic one. Select your payment method. I'm using balance since I have free credits. After that, create a sub-account, set username and password and click Save. Now choose how many proxies you want. Click Generate. And just like that, your proxies are ready to use in your code. I have placed the all relevant links in description of the video. You can check it out. You can even get an 20% off as a new user sign up. Now let's continue to our code. We define a function that takes a URL and returns the cleaned, visible text content scraped from that page. We send a GET request to the target URL using a browser-like user agent header and our proxy. With a 15-second timeout, raise_for_status throws an error if the response indicates failure. We pass the raw HTML response into a BeautifulSoup object so we can navigate and extract content from it. We remove all script, style, nav, footer, and header tags from the parsed HTML to avoid extracting irrelevant noise like code or navigation text. We extract all visible text from the cleaned HTML, then use regex to collapse multiple spaces and whitespace characters into single spaces before returning the result. If any network or HTTP error occurs during scraping, we catch it and return a descriptive error string instead of crashing the app. We define a function that takes scrape text and a desired keyword count, then uses TF-IDF to identify and return the most significant words. We split the full text into sentences by period, filtering out any fragments shorter than 15 characters to build a meaningful corpus for TF-IDF analysis. If the text is too short to produce enough sentences, we fall back to treating the entire text as a single document to avoid TF-IDF errors. We initialize a TF-IDF vectorizer that automatically removes common English stop words like the and is and limits the vocabulary to the top 1000 most frequent terms. We fit the vectorizer on our sentence corpus and transform it into a TF-IDF matrix where each row is a sentence and each column is a word's importance score. We sum the TF-IDF scores for each word across all sentences, giving us a single overall importance score per word. We retrieve the vocabulary words and flatten the sum score matrix into a 1D NumPy array so we can sort and rank them easily. We sort word indices by score in descending order, take the top n indices, and map them back to their actual words to return the most important keywords. If the text is empty or contains only stop words, TF-IDF raises a value error. We catch it and return a friendly fallback message instead. This route serves the homepage, rendering the HTML UI where users can submit a URL for scraping and keyword extraction. This route handles post requests from the frontend, parsing the incoming JSON body to extract the target URL submitted by the user. We validate that a URL was provided, returning a 400 baud request error with a clear message if the field is missing. We call a scraping function with the provided URL to fetch and clean the page's visible text content. If the scraper returned an error string, we forward it to the client as a 500 internal server error response. We pass the scraped text to our TF-IDF function and request the top 6 most important keywords from the page content. We return a JSON response containing the original URL, extracted keywords, and a 300-character preview of the scraped text for display in the UI. This starts the Flask development server on port 5000 in debug mode, enabling live reloading and detailed error output during development. Now here is our index.html, where I have designed the all-user interface. If you'd like access to this code, just send me a message on our Discord server.